Hey, all right, so let's look at some questions from the Module 4, Lesson 1 problem set. Lesson 1 is essentially just about, um, introducing you to what a percent is and the percent sign, even though I'm sure you've seen this stuff before. Sort of just reminding you. So, this symbol here, the percent symbol, just means hundredths, right? You could read this percent symbol as hundredths, like 1% is the same as 1/100ths, or 1 out of 100, or 1 per 100. These are all like equivalent ways of thinking about it. And you could think of this percent symbol as being the same thing as taking the number that's in front of it and putting that number over 100 in a fraction. So these two things are equivalent, 1/100th and 1%. So we need to be able to be flexible and move back and forth between percents, decimals, and fractions, because we don't really do math with percents too much per se. We tend to convert them to a decimal or a fraction to complete our math with, but then maybe represent our answer as a percent because those are easily understood by most people. So let's go through a few of these. It says create a model to represent the following percents, and the first one is 90%. So you can use this space over here on the other side of the paper on page 4, where there's like this big empty space here underneath where we did a card activity in class. If you want, I'm gonna make one of these models like here. So there's lots of different ways you could draw these models. They might be circular, they might be like a box. If you hear pitter pattering in the background, it's Panda Bear the dog. What are you doing? Hey. Here. Let's see if she can make a cameo. Oh, there's some snout. It's Panda Bear. All right. Anyways, go sit on the couch. All right. So I'm making a model for 90%. So if this is my whole thing here, this box that I drew, and if I were to cut this into 10 pieces, I wonder if I can do this evenly. I might have to extend it. 1, 2, 3, 4, 5, 6, 7, all right, 8 and 9, and then this would be the 10th. And so if I were to shade in 9 out of those 10, that's the same as 90%. So here's my model for 90%. And then the next one says to make a model for 0.9%. And so that's way different, right? 0.9 is smaller than 1. And so I have a percent that is smaller than 1%. So if I were to think about, like, I'll make the boxes basically the same as I made in the previous one. Each one of these boxes is 10%. And so 1% would be 1/10 of one of these boxes, and 0.9% is going to be ever so slightly smaller than that. So I mean, there's not really any way for me to do this perfectly, but I'm going to say that, like, so that's actually, like, looking at it, that's too big. I shaded too much. That looks like it's about 1/4 of this box. So really this is like 2.5%, but that's just because the tip on my marker is like too fat for me to be able to do this. So oh well, we'll call that good enough. All right, I'll leave the other two. Number 2 says Benjamin believes that 0.5% is equivalent to 50%. Is he correct? Why or why not? No. The fraction 1/2, that is equivalent to the decimal 0.5, and that is equivalent to 50%. All those things are equivalent, but that's not what we have here. We have 0.5%. And so, I mean, if you just look at the two things we have equivalent to each other here, or supposedly equivalent, 0.5% and 50%. The fact that they both have percent symbols on them kind of makes that not work. It should make that sound really weird. This one is much, much smaller than this. So I think what Benjamin in the problem is getting mixed up is the fraction 1/2 without the percent sign would be equal to 50%, but not 0.5%. All right, order the following from least to greatest. So every year when I look at students' work on this one, they tend to have made a lot of mistakes. So let's go through it. Let's see here. 10,000 divided by 100, that's the same as just 100. So I'm going to write that just to help myself out. And so here's 10, here's 1.1. These are probably some of the bigger ones. Okay, 0.001, that's the same as 1,000th. That'll be smaller than this 1/10th. Now, 100%, that's the same as 1. 1/100th, that's the same as 1%. Now this one is really, really small. Let's look at 0.001%. That's the same as 0.001 over 100, but we don't really like to have decimals in our fractions. So if I were to multiply this by 10, 100, 1,000, that would get the decimal point to over here on the other side of the 1. So I could multiply top and bottom of this by 1,000 and get 1 over 100 times 1,000 is 100,000. This is 1/100,000th. This is by far the smallest one. So as I make the list, I'm going to put 0.001%, that's what I started with, as the very first thing. And I'm not going to fill out this whole list for you, but I will tell you that I believe that the last one here, the 10,000 over 100, the 100, or another way to think of this is 10,000%. Pretty sure that's the biggest one. All right, I'm going to let you order them, all the ones in between. All right, and then question number 4, I think this is the last thing on the problem set. Let me check the back set real quick. Yeah, this is the last part of the problem set. It's just your basic standard exercise of writing a number 3 equivalent ways. Once as a fraction, once as a decimal, once as a percent. In fact, on your quiz, you're going to have a table that looks exactly like this. It won't be as big. It'll probably only have like 3 or 4 questions on it, not 12 or however many this is. And you'll have to fill in this exact sort of thing on your next quiz. So 100% as a decimal, that's just the same as the number 1 or 1.0. And as a fraction, that's just the same as 1, which we can also write as 1 over 1, just so it looks like a fraction. All right, so if we have 0.0825 as a decimal, we can write that as a percent by just thinking about what happens when we move this decimal place over 2 times. That's the same as multiplying it by 100, 8.25, which is corrected by the fact that this percent symbol means to divide by 100. So we can multiply this number by 100 to write it as a percent, because the percent symbol sort of divides it back as 100 for us and makes it equivalent. Then as far as writing it as a fraction, well, we have a few strategies. We could just write 0.0825 over 100 and then do some simplification from there. But another way is to just think, is there a way that this 825 gets to like an even number for us to work with more easily? Well, if I take 825 and multiply it by 4, so 0.0825. If I multiply it by 4, sorry, I'm just a little bit off the screen over here. I'll do it over here instead. 0.0825 times 4. So this is the sort of thing where you got to be kind of like intuitive, creative, kind of think about tricks when you're doing math, and even be able to spot something like this. Actually, now I'm starting to second guess whether or not this is going to work out the way I want it to. Let's see. So 4 times 5, that's 0. I'm going to carry the 2. 4 times 2 is 8. I got this 2 up there, so it gives me 10. I'll carry that. 4 times 8 is 32. I add that 1, I get 33. So 4 times 0.0825 is 0.33. Nope. This actually is not going to do what I was hoping it would, actually. I think I was thinking about 0.085. If I multiplied that by 5, that would have given me 34 either, and it wouldn't have worked either. Seems like I should be able to multiply this by 12. Now if I multiply by 12, I get 99. Nope. So my goal here was to try to figure out a number that I could multiply 0.0825 by and get 1. And then I would have shown you an easier way to build the fraction from there. But it's not going to work, because when I multiply this by 4, I get 0.33, and I know that if I were to multiply that by another 3, or in other words, multiply the whole thing by 12, I get 0.99, not 1, like I thought. So it was close to what I was thinking, but not quite. So instead, we're going to do it. We're going to write this fraction this way. We're going to write 0.0825 over 100. Not over 100. Let's see here. 1, 2, 3, 4. We have 4 decimal places. So this is over 10,000. This is 8. Oh geez. It's spring break, you guys. I haven't done this percent stuff in almost a year, and it's spring break. Give me a break. All right. So what we have here is 825 1, 2, 3, 4 10,000s. All right. I'm working this one down here now. 825 10,000s. A good thing I'm practicing this over spring break before you guys come back into class, so I'm not so rusty. So, the reason I wrote 825 10,000s is because I counted the last decimal place in the decimal. So the decimal is here between the two zeros. You can't see it anymore because I've been writing. Then this is the tenths, hundredths, thousandths, 10,000s. So what I have here is 825 10,000s because that's the last decimal spot. So I wrote 825 10,000s. And I could simplify that fraction further, but I'm not going to because I don't want to mess with it anymore because it caused me problems. All right, so let's do another one. This one is, I'm going to count to the last decimal place. I've got tenths and I've got hundreds. The 5 in the 6.25 is in the hundredth spot. And so what I really have here, if I ignore the decimal point now, is 625 hundredths. So if you just always use the last decimal place in the number as the denominator, and then just write the number in the numerator, ignoring the decimal point. So this becomes 625. The previous one just became 825 instead of 0.0825 or whatever. That's always a strategy that will always work for you in these. And then when you want to go from a decimal to a percent, just move the decimal place 2 spaces to the right. So this 6.25 becomes 625%. The reason we can move the decimal place 2 spots to the right is because it's like we're multiplying the number by 100, and then that action of multiplying it by 100 is corrected when we put a percent sign on there, because that percent sign means to divide by 100, and those two things just wind up canceling each other out, keeping the number equivalent. All right, I feel like I was sort of confusing the first couple times I did this, so normally I would stop here and say you can do the rest, but I'm going to do one more just to see if I can clarify a little bit better. So here we have 1/8 of a percent. So I can write that as a fraction as 1/8 over 100, because that's what the percent sign means, right? To divide by 100, so 1/8 100ths. If I think about keep, change, flip, this is the way I like different math teachers will teach us differently, but the way I like to think about it is 1/8 100ths. Well, that's the same as 1/8 divided by 100, right? If you think about this this lower fraction bar just being a division sign. And so that's the same as doing 1/8 times 1 over 100, right? I'm keep, change, flipping on this divide by 100. And that gets me 1 over 800. So we could write, if we don't want to have the compound fraction, when you have a fraction in a fraction, this 1/8, sorry, let me move this up, this 1/8 over 100, it's called a compound fraction. If we don't want to have that, then we could just write this as 1/800th. And then to write that as a decimal, honestly, my recommendation on this one would just be to put that into a calculator. What is 1 divided by 800? I happen to know that 1 divided by 8 is 0.125, right? That's just a math fact that I just happen to have memorized. 1 divided by 8 equals 0.125. And if I'm going to divide by 800, I know that those extra 2 zeros are just going to move this decimal point to the left 2 more times. So if you punch this into a calculator, or if you did it by hand, you should have got 0.00825, which makes sense because the thing we started off with was less than 1%, 1/8 of a singular percent. And so our decimal answer should definitely be less than 1/100th, right? We should have zeros in the 10th spot and in the 100th spot in order to have something that's less than 1%. Oops. And I wrote an 8 here just because I was thinking about 8 dividing, but it really should have been this 125 like I got when I divided earlier. See how I wrote this 8 here? That's just a mistake. I'm just making all sorts of mistakes in this video. Oh well. It is what it is. When it comes to math, we make mistakes, we learn from them, we live with them.